Okay, there we go. You guys doing all right today? Good. Have a nice weekend? Hope so. New week off to a good start, hopefully. Okay. Could I answer any questions before we get started? All right, so when we left off last time, we had basically been going through and talking about active records validations or active model validations. We had essentially found out that in our active record object classes, we have access to this wonderfully useful little method called validates. The basic way the validates method works is we call the method. We can then give it the name of any of the different attributes or fields that we want to perform a particular type of validation on. And then there are a handful of different built-in validations that can be done usually quite easily. So for example, we call validates, we tell it this validates is going to affect the title, author, ISBN, page count, and publisher. And the particular validation we're doing in this case is for the presence of a value, basically making sure it can't be blank. Right? So last week we talked about a bunch of these different types of validations. We talked about presence, which was making sure something isn't blank. We saw how we can validate the length of a value that's present in a field. We could validate numericality, basically making sure something is a number of a particular type. We talked about validating uniqueness. The trickiest part of that was uniqueness with a scope. And we finished up last time by being able to talk about validating the format of a piece of data. Right? With all of those different types of validations, there were generally different options that could go along with them, right? Like with uniqueness, for example, right? The is true basically says we are validating for uniqueness, but we could then choose whether we wanted to allow blanks or not. We could choose whether we wanted to limit the uniqueness to a particular scope, right? With numericality, there were a lot of options specifying that it could only be an integer, specifying that it has to be greater than or less than some particular number. All the different validations we talked about had different options that could be configured along with them to make them behave more or less the way that we actually want. Right? What we have this week then, today, is a handful of other validations, built-in validation types that we can use with the validates method, although we're through the ones that we will probably use the most commonly. Right? Then we can talk about custom validations, basically how we can set active model up to validate in situations where there is no built-in validator to do the work for us, and we actually do have to do custom validation. We actually do have to write our own validation. Right? So for a few of these next ones, I might just throw them in as something like comments. Right? One of them is checking for confirmation. Right? I'm sure you've seen web pages, websites where you go and you fill out a form and they ask you, for example, for a password. And you have to type your password twice. And the password, when you type it both times, has to match. If it doesn't match, it's not valid. Well, the validates method has a built-in type for that. We don't have anything like a password or anything that would really be applicable to this in our book model here. So I'm just going to say I'm validating some field. Right? And what I could do is I could say that I want to validate for confirmation. Right? Matter of fact, I should just be able to say confirmation true. Okay. Essentially, the way that would work, right, is that if my field, the original field, the actual data member on the object was called field, then what Rails would look for is it would check to see if the value of that attribute was equal to another value called field confirmation. Right? Field confirmation would not be an actual attribute of our object. It would just be sort of a dummy form field we would throw in. Right? So the value of that dummy field and the value of the real field, the value of the actual attribute, would both end up being passed to the validation. And this confirmation validation would check to make sure that those two had the same value. Otherwise, they would be considered invalid. Yeah, I was just saying that's what it's basically doing, is it's checking for equality between whatever our field name is and another field that has the same name as our original field but with underscore confirmation thrown on the end of it. So if we were validating that, if we decided for whatever reason that the page count was something that had to be confirmed, we wanted to make 100% sure we didn't make any errors entering the number of pages in a book. Right? Then what we could do is, instead of field, we could say we want to validate page count. Right? So the original field name would be page count. Right? And what this validation would then look for is that there was another field called page count underscore confirmation, and it would insist that those two be equal, or the whole thing would be considered invalid. All right? So I don't really want to do that, so I'm just going to comment it out, but that would be the basic idea. Right? There is a built-in validation type to handle those situations, where we want to have the user enter a value twice to confirm that they did it correctly. Okay. Another common situation, I'm sure you've run into lots of times, you go on the web, you register, you fill out something, you buy something, and they always have that little checkbox at the bottom. Do you agree to our terms and conditions? That sort of thing. You've seen those, right? Sure, right? Well, there's a built-in validation type for that as well, called acceptance. Right? Essentially what we can do is we can say validates, we could give it some field name, the field that actually is the checkbox, for example. Right? And then we can tell it we're checking for acceptance. Acceptance, there we go. Okay. When we check for acceptance, what we would do is we would put in an accept option and then some actual value. Right? And basically what we'd be doing is we'd be telling ActiveModel, right, that when the form is submitted, when the data is received for the object, there should be a thing in it called field, whatever field's real name is. Right? And that field should have the value that we put in for accept. If it has any other value, it's considered to be invalid, as if they didn't check the checkbox. Right? Whereas if it does have the value that we put in for accept, then that's what we're looking for, and at that point we know that they have accepted our terms and conditions, or whatever our checkbox was supposed to be checking with them for. Right? In a way, I guess it's basically like checking to make sure that a specific value is in a field, is really what it basically comes down to. If you think about it, there aren't many cases in web forms where the user is required to type a specific value in a field. Right? Here's a first name field, type John. No, that never happens. Right? About the only time when you do run into that situation where there is one and only one acceptable value that a user can fill into a form is with things like check this checkbox if you've read our terms and conditions and agree to them. Right? I've even occasionally seen ones where they give you something like a text field and you have to type accept or yes, right, to show that you actually have read it and agreed to it. And that's basically what this particular type of validation is meant for, to confirm that there is a specific value associated with a specific field. Right? Again, not something I really have any reason to do here with our books, so I'm just going to leave that in there as a comment in case we happen to need it in the future. Last two built-in validation types that I was going to talk about are validating the inclusion or the exclusion of some particular value. Right? Must include or exclude. Right? We could do something like, say, validates, we could give it some field or multiple field names. And then we could specify the type of validation is inclusion, okay, where we could then say that the value has to be in something, in some collection. Okay. The actual collection that I specify is usually going to be a hash or an array. Okay. You can also do exclusion. Right. What would be a good example of where we might use this? If we wanted to be really careful about something, it would be pretty smart. Say for one reason or another on a form, we give a user a select box, a drop-down list of options that they can pick from. Okay? We could do just any other type of validation potentially on the value that we receive from that select box. Kind of take for granted the fact that the user shouldn't be able to select anything that isn't in the drop-down that we've provided. Okay? But of course nowadays with more modern browsers, with the fancy scripts we have like Grease Monkey and things, where people can actually go in and live edit the content of a page they're looking for, it would be pretty smart that if we gave a user a list of options and a select, we might want to also then put in a validation to make sure that the value the user selected was actually one of the values that we provided, not something that they somehow tricked in there themselves. So if I had a shipping form and I gave the user a choice of fast, medium, or slow shipping, right? I could put in a validates shipping field inclusion in, and I could put together, say, an array of strings where I have options for fast, medium, or slow. Right? That way, if a user tries something weird, right, they hack into the page and they put in an option for super fast free shipping, it of course probably wouldn't actually work or get them anywhere. It could cause problems in our scripts. Right? But if we go ahead and validate and make sure that there's no way that they were allowed to, there was no way that we would accept a value that wasn't in the set of values that we had already determined were acceptable, then we could avoid the whole issue. So inclusion or exclusion potentially could come in handy for those kinds of situations. Yeah? Oops. There we go. All right. I think that's pretty much it for the built-in validation types. There probably are a few more that I haven't talked about, but hopefully at least get the idea. If you guys found any good documentation you like? Yeah, the API doc's good. I don't know why, but for some reason the API doc for both Ruby and Rails, I'm just never all that crazy about it. It's okay. I can usually find what I need when I need it bad enough, but it seems like it's always more work than it needs to be. Almost always, it seems like when I'm looking for help with Rails, I end up coming back to the Rails guides. Have you found those on your own? They're nice, right? There's a different version of the Rails guides for all the different versions, right? The Rails guides are split up into lots of different sections depending on exactly what it is that you're looking for help with. Seems like typically if I just search for Rails plus whatever it is I need help with, Rails guides almost always comes up in the first couple hits on Google. So here I just searched for Rails and validations, and sure enough, right, comes up on a nice help document, right, that talks about different validation types. And here they've got a list of a lot of them. Uniqueness, presence, numericality, length, inclusion, format, exclusion, confirmation, associated. We didn't talk about that one. Acceptance. Yeah, I think we hit most of them. And they talk about a lot of the different options in there, right? How the errors are handled. We played with that last week on the console. So anyway, thought I'd point that out just in case you hadn't run into those Rails guides on your own. They are truly helpful. I like them a lot.
They all go in the model file? Yeah.
Yeah, the validations are in the model file. You got it. All right, so what do we do now in situations where we have some piece of data that we need to validate, but there is no built-in validation type for it? Got to make our own. Got to roll our own custom validation, right? Just as an example, let's say that we add a price field to our books. So in addition to all the data our books already contain, let's say every book also has a price stored with it, right? Let's go ahead and get that bit out of the way. Let me jump over to my console, right? I'm going to do Rails generate migration. I'm going to tell it the migration is going to be called add price to books, and the field I want to add is called price, and I'm going to set the data type to float. So Rails G migration, add price to books with underscores, price : float. Right? Hit the enter key, that'll generate my migration file for me. If I then run rake db migrate, it will apply that migration file, and now my books should have a price field. Okay. All right. Now, as far as validating that price field goes, there are some pretty obvious ones. We could say validates price numericality. True. Has to be a number. Nothing else can be accepted for the price. Okay. We could fire up the console, see how that works. There we go. If I take a look at book.all, I see all my books, and sure enough, over on the far right side, there's now a price attribute in the little HIRB column that's made for me. If I try to make a new book, and maybe I set a title, but nothing else, so b equals book.new, title colon test as a string. If I try to save my book, I get back false. The book won't save. If I go to take a look at the book's errors, let me look at specifically the errors for price. Sure enough, the validation for price seems to be working. It does come back and give me an error message that price is not a number. So good so far. Okay. But what if there was something special we wanted to do with price? What if, for example, there was a corporate policy, business rule, basically, that said that any book that has more than 1,000 pages cannot be sold for less than $100, no matter what. Right? And just to make sure that we never accidentally get a book with more than 1,000 pages that cost less than $100, we might want to put in a validation for that. So whoever's doing the data entry for our books doesn't inadvertently violate our business rule that we can't have thick, cheap books. Right? Well, there is no built-in validation for that. As a matter of fact, in that kind of situation where one attribute of an object determines what acceptable values another attribute can have or not have, almost always in those more complex type situations, there's not going to be a built-in validation type, which means we then have to create our own. Okay? In a situation like this is most likely going to be a type of validation that will only be used in one place. Validating that page numbers determines price is not something I feel would be all that likely to be used anywhere other than here in my book model. Right? So there's a couple of different ways we can write custom validations. One of them is more reusable than the other. Right? In this particular case, I don't see any particular reason to make this validation all that reusable. Right? So the way I could do that is here I could actually create a new class of my own, right? And I'm going to call it the price validator. When I create this new validation class, what I do is I set it up so that it inherits from active model validator, which essentially gives me the foundations of a class that has the ability to be able to interact with active model when it comes to doing things like validations. Right? This class has to have a single method in it called validate. And this method, when it's called, will be passed a record. The record is basically all the data that has been given to us in order to create a new object. So in this case, what record would contain is all the data that's been put in order to create a new book. Essentially, it's a new book that's being passed to this method. Right? What this validate method then needs to be able to do is it essentially needs to be able to return true or false, indicating whether record appears to be valid based on whatever criteria we determine this method should check for. Right? So if we wanted to say less than 1,000-page books, or more than 1,000-page books have to cost more than $100, something like that, we could say something like if record.page count, so if we have a page count and record.page count is greater than 1,000, And then I'm going to say and record.price, if we have a price, and record.price is less than $100, then essentially we have a problem. So if there's a page count and the page count's over 1,000, and there's a price and the price is less than 100, right, we've got an issue. Right? Oh, I said before that this returned true or false. I don't think that's right. I was thinking that was how it worked, but it's not. What we have to do is we have to actually store an error message about this. Okay? What we would do is we could say in the record, right, in its errors array, the same errors array that we've been playing with over on the console, I can say for the price field, right, put in the value is too cheap. Would be the basic idea. That makes sense? If we have an error message then stored for that particular field, active record should recognize it, refuse to save the book, right? And then it's up to the user, whoever's doing something with this book, the implementer, to recognize that there's an error message there and display it or decide how to actually deal with it. Okay? The one other thing here we might want to do is, do you remember that with most of our other validation types up here, we had the option of passing in a custom error message? Like up here when I was doing the validates presence of all these fields, I put in a custom error message. Message must have some content, right? Which then replaces the standard error message, which would have been cannot be blank. If I want that same basic behavior down here in my custom validator, right, if a custom option like messages is passed when we call this validator, when we implement this validator, it should automatically be available to us here in this method. It would be available through a thing called options in a key called message. So essentially what we could do is something like that. If we find out that the book is too cheap for the number of pages it has, for the price error, we could either take primarily the options message, the message that whoever actually implemented this validation had specified. Or if that doesn't exist, if that's faulty in some way, the default message of is too cheap. So at that point, we would basically have our own custom validation that we could use. The only other thing we would need to do then is to actually tell it to be used. Right? We do that by using the validates_with method. So here inside the book class, I could say book validates with price validator, the name of my class. So an instance of price validator should be created. It'll take the new book that we've asked to have saved. It'll pass it as record to the validate method. The validate method will either store an error message or it won't. Active record should then recognize if an error message was saved or not, and then based on that decide whether it should actually save the book, write the book to the database. Want to give it a try? Let me jump back over to the console. I'm going to reload it. Okay. Let me try creating a new book. For this new book, I'm going to set the price to $50. I'm going to set the page count to 1001. So that book should be in violation of our price validator. Uh-oh. That's not the way it's supposed to work. Let's see. Syntax error, unexpected keyword and. Where did I go wrong with my ands? Did it not like me breaking the line there? Let me try putting that all in one big long line. Let me reload the console again and give it another shot. Book.new, price of 50, page count of 1001. No, still doesn't like it. Mass assignment security. Ah, okay. So price, I didn't tell it to accept price. So I need to come back up to the top of my book class, and I need to make sure that price is an accessible attribute. There we go. Third time's a charm. Book.new. Price is 50. Page count 1001. Aha! Now we made a new book. Now if I try to save the book, it did not save. Of course, there's a million things wrong with the book, so of course it didn't save. But what happens if we look at B errors for price? Is too cheap. Our message. Good. So it looks like it did correctly recognize that that book's price is not high enough considering the number of pages. If I set the book's price to $101, try and save the book, look at the price errors. There are none. So it looks like my validator is working correctly. Can we pass it a custom message? Let's see. If I say message should cost more. Let me reload. Make a new book. Try to save book. Look at errors. Should cost more. So it's recognizing our custom error message. So I think it's doing everything that it was meant to do. Right?
What does options message do again?
Anytime we pass any additional information here to the validates with, right? With validates with, we always tell it the name of the class that has the custom validate method in it. Right? Anything beyond that is an extra option, basically a hash of extra values. What happens then, right, is that we have the ability inside the validate method to look at that hash of options. So here we were saying in that hash of options, is there a message key, right? Which there is. We put that in. If there is, it takes that. Otherwise,
Or if there isn't, it'll just round this to
right,
Okay.
yeah. If options message is non-existent, if it's nil, essentially, then it won't use it. It'll use as too cheap as a default message instead. That's it. Okay. You can see how this would not be wonderful if this was something we wanted to do in multiple classes. If this is something we're only going to do in the book class, then this way is just fine. We just write it directly into the book class and implement it. Right? If, however, we had 5 different classes, 5 different models in a project that all needed this particular validation, copying and pasting would not be a very dry thing to do in order to make this validator available to all of those different 5 classes. Okay? Take, for example, validating email addresses. Okay? Validating an email address could very well be something that we not only do in multiple models in the same project, but probably something we're going to do from project to project to project. So if we wanted to implement a custom email validator, right, that might be something that we want to do in a more reusable way. Right? It certainly could be done in this way, right, where we would simply have a email validator class that we would write. The validate method would receive the record that had the email address in it, and then we could just use a regular expression or whatever, right, in order to check to see if the email is what we want it to be. Okay? The only problem is, in that case, it wouldn't be reusable. So if we wanted it to be more reusable, there's a different way we can set this up. Basically what we can do if we want, another way of doing a custom validator, is that we can create a class that inherits from active model each validator, slightly different sort of base for the new validation class. And this new class that we create, we can store outside an actual model class. Very often where they are kept is under config initializers. Right? Under config initializers, if you stick a class in there, it will automatically be recognized whenever your Rails application boots up, essentially. That's why they call it initializers. Anything you want to be recognized and put into effect when you first boot up, you can put there. Right? So here under initializers, let me make a new file. Let's see, what is that? Command Option T? No, that's definitely not it. What is it? New tab. Option Command N. Rats. I thought T for tab. N for new. Alright. I'm going to save this new file under that initializers folder. And I'm going to call it email validator. .rb. Actually, wait. Email validator. That way. .rb. Okay. Alright, so here when I create this type of custom validator, right, I make a new class. So this is going to be class email validator. Right? But instead of inheriting from active model validator, like I did over here previously, right? Instead with this one, I'm going to inherit from active model each validator. Yeah. Okay. Once we get the basic structure of it, inheriting from the correct class, after that it should be a whole lot like what we had a second ago. The actual validate method that we put into it is now called validate each. And it won't just be past the record. It'll be past the record, the attributes, and the value. Now the value is what has been proposed to be set for a particular field, which is the attribute. Right? So attribute is the field that a value needs to be set to. Value is the value that we're wanting to put into that field. So this is a little bit more genericized than the way we did it a second ago. Right? The way we did it a minute ago, that particular custom validator only would work, right, in a situation where we are specifically looking at something that had fields called page count and price. It could work for nothing else. Right? That is built into the validator itself, which is why down here when we call it, we don't have to specify what fields to validate. What fields to validate are built into that particular validator all by itself, directly. Over here with our email validator, because this is supposed to be something that'll work in a more reusable and open way, right, we don't make the same assumption that we always know exactly what the field is going to be called. Right? It could work in a situation where the field is called address, or where the field is called email, or where the field is called respond to. Right? So the actual validate method here itself has to be told what the actual name of the field is. That's what the attributes option is. And then value is what they are saying we want to put into that field. So essentially we need to write a test that checks to see if value is an acceptable value to go into attributes, or a field of that name. Instead of attributes, that should just be attribute probably. It makes a lot more sense. It's just one attribute. Right? The record is there, containing all of the other data that goes along with this new object that's going through this validator, in case we need to compare value against some other value. Right? Like, for example, if an email address is required only if a phone number wasn't given. We could check the record to see if a phone number is already there. If there's already a phone number, then we could just give this an automatic pass and say, well, you don't even have to have an email, right? Whereas if there's no phone number, then we look at the email that should have been submitted as value, right? That needs to be put there into attribute, whatever the name of the field is. You with me? Let's write it up and see if that snaps it into place anymore. Okay? Essentially what I'm going to want to do is into the record, into its errors array, into the field called attribute, right? Whatever attribute's name is, that's where the error is going to go. Right? We want to stash in there, okay, an error, right? Kind of like before. The error might be something that the user determined with options message, just like we had a minute ago, or it could be some default message that we put in, like is not a valid email address. Okay. That's really at the heart of what we want to do if there's a problem. Okay. To actually determine if there's a problem, we can just put in whatever test we want to put in. So I could say something like, unless value matches some regular expression, then put that error into the errors array for the record. Then we just need a regular expression. Do you have any good email matching regular expressions off the top of your head? I copied one into my notes, and I'm hesitant to use it because I could not even explain how it works. I'll go ahead and put it in. Maybe you guys can help me with it.
There's so many different ones for emails. It's ridiculous.
There really are.
There's some that are like really short, there's some that are super long.
This one's kind of medium. I don't remember what it was about it that caught my eye as seeming like a good one. Certainly, one of the things I liked about it was that it's not by far the longest one that I've ever seen. But it appeared to be fairly comprehensive. This is the part that kills me right there. I think that's it. She's a beauty, isn't she?
Shouldn't be minus sign before the second A. Or AZ09. Or, no.
This one?
Yeah.
Yes, I believe so. All right. As far as my understanding goes, \A means beginning of the string, \Z means end of the string. Right? So kind of like the circumflex and the $sign. A little more specific in certain situations. We're saying the first part of the email address, this bit right here, can be anything except an @ sign or a space. Right? No @ sign, no space. After that, there then has to be the @ sign, the standard @ sign in a email address. Right? And then this little bit is, what do you call it, a callback? Something like that. Never been able to get a good understanding of those in regular expressions, so that part loses me. Next part, though, makes pretty good sense. We're saying the next part of the email address right through here has to be one or more hyphens, letters, or numbers. So that's basically the domain name, right? Followed by a period. That whole thing then can repeat because there may be multiple parts to the domain name, like ingenio.us.com. Right? And then finally, after all of that, there should be basically the TLD, which is always going to be alphabetic, no numbers, at least 2 letters, but potentially a good number more. And of course, the I at the end makes it non-case sensitive. So I get lost as to what the purpose of that little callback guy is right in there. Not sure about that. If that's even what it is, I might be completely misreading it.
Isn't the question mark an option? Is an optional?
Yeah, it means that whatever precedes it is 0 or 1 times, but here nothing precedes it. And the colon after it, I think those two together become something of a placeholder. But I'm lost as to exactly what they're holding the place for. So, not sure. Not sure. But anyway, we'll see if it works, roughly. All right, so this should pretty much be our custom email validator. Right? We ought to be able to apply it to any field. We can go to any field we want and we can say this field has to be an email address, a valid email address. That field has to be a valid email address. Right? So for example, if we go back over to our book class, if I just call the validates method like I normally would, and I say for the author field, email has to be true. It becomes almost indistinguishable from the built-in validators. The format of how we call validates, give it a field name, and then specify options and such, works the exact same way it did with all of the built-in validations that we looked at. Okay. The way that particular statement should let Active Record know that we're talking about our email validator is a little bit of the trick of the names. It's a little bit of that convention over configuration stuff that Rails is so famous for, so good at. And that is that if I say that there is a validation type called email, what Rails will do is it will automatically look for a class that's available called email validator, and that's exactly what I called my file. So calling it email validator was no mistake, or at least it wasn't meant to be. We'll see if it's a mistake or not when we try it out, right? It was no accident that I picked that name. I picked that name specifically so that when I actually run the validation, I would be able to say validates author is an email, basically. How it ought to then work is the field name that I provide here becomes the value for attribute over here. Right? The actual email address that's being submitted when I create a new book will become the value, and the book itself is the record. So with the validation set the way that I have it, it ought to take whatever email address I submit as the value for author. It should check to see if it matches this regular expression. If it does not, then into the errors field for author, because that's what I told it that the field that should be validated is an email address, it'll either put a custom message that I supply or the default message, which is not a valid email address. Oh, let me jump back over the console and let's see if it works. Reload. Nothing's blown up yet. That's a good sign. Book.new author. Let's say test. Uh-oh. Unknown validator, email validator is the message I got. In a way, that's at least a little bit hopeful. Reason it's a little bit hopeful is that when it looked at my book class and it saw me saying validate email true, it did put that into a file or into a class name the way I expected it to. It saw email here and said, okay, that must mean that there is a class somewhere called email validator. That's what it's looking for. It, however, did not find it. Let me try exiting out of the console and then starting the console up again. Maybe calling reload isn't enough to reload the full environment. Getting out of the console and going back in, hopefully though will. Ah, no error. If I try to save my book, if I go to look at the errors for author, that works. Is not a valid email address. Looks like I got it. Do you follow how it's all getting put together? Kind of a long story. Whole thing starts by calling validates with something that's not a built-in type, which then leads Rails to look for a class that has that name followed by validator. So you make one. Putting it in the Initializers folder causes it to load whenever the Rails environment loads, like when we load the console. Then, whenever it comes time to actually do a validation, Rails knows to call the validate each method for every field that we've told it to validate as that type. Passes the record, passes the field, passes the value that's going to be set. We do our validations and store error messages if there are any, which is what then triggers in active record the reluctance to actually save. So if I go back to my model and tell it to verify that the validate, I guess I should say, validate that the author and the publisher are both valid email addresses. It'll call the each validator here on each one of them. I think that's why they call it an each validator. It probably is just cycling through all the record names it's given. Let's see. Reload my console again. B equals book.new. Author is test. Publisher is test@test.com. There we go. B.save. Book did not save. Look at the errors for the author. It says it's not a valid email address. Look at the errors for the publisher. There is no error message there. That was a valid email address. I believe it's working correctly. So these custom validators are definitely a little bit more work than using the built-in ones. But overall, it's wonderful the way they have the whole validation system set up in this nice, neat way, where if we do need to do a validation, it's so easy to tap into, so easy to get it performing easily. Right? Either in the case of a validation that isn't going to be reused much or at all, just dropping a quick little class into our model that performs whatever validation we need it to perform, or in the case of something that we may have the potential of reusing all over the place, just creating a quick little class, dropping it into initializers, potentially then even taking that file to other projects. Right? Technically, I guess once we find a regular expression and we've set up a validator like this, we shouldn't ever have to worry about tracking down another regular expression for validating email again. We ought to just be able to take this wherever we go, always be able to validate email quickly and easily. Surprised that's not a built-in one, wouldn't you think? Somebody should just make an authoritative decision about the correct regular expression to use to validate email addresses, and then just build it in, and then we don't even have to think about it anymore. But one way or another, that's good. Okay, let's call that round one of active record. Can I answer any questions about anything we've talked about so far with active record? There's still more to come, but before we jump in for active record round two, I wanted to back off from it for just a little bit and go back and talk about migrations. Migrations are something that we've been doing rather frequently, and I've given the slightest of explanation of. I just wanted to give a little bit more of an explanation of migrations to make sure that those are okay with everybody, since they're something we're just going to be continuously doing more and more in the future. Right? Overall, what the basic idea is that when you're developing a web application, basically when you're developing any application that has a database associated with it, you would be quite fortunate if you, from the very first moment of work, knew exactly what the structure of that database was going to be. You knew all the tables, you knew all the fields, everything was named right, all the relations were set up. Right? I would say that technically that's possible to do, right? If you really invested heavily Right? In the design of that database, maybe you could have the database completely figured out before you ever wrote a lick of code. Right? But that's usually not how it goes. Usually the database tends to mutate or evolve over time as you work on a project. Right? You start off with a table and you think, well, I'm probably going to need this table, I'm probably going to need these attributes in this table. But then when you start working, you realize, oh, rats, I can't actually do what I was going to do with that particular field having that data type, or without having this one particular field available. Need somewhere to store this other piece of data. There's almost always, it seems like, changes that occur, right? So what do? Right? The only reason that it's really an issue is that, again, in the real world, the computer that you're developing your web application on is probably not the computer where that web application is going to go into production. At some point, you're almost certainly going to have to move that application from development onto a production server, right? That's certainly one thing that happens. Another thing that happens is you may very well also be sharing development responsibilities with others, right? You're not the only person working on this application. Other people are working on it as well. Right? So when you've got those kinds of situations, where you've got the situation where you need to be able to take your application from one computer to another, or you've got a situation where multiple people are working on it on different computers, how do you keep all those little mutations, all those little evolutions of your database in sync? Right? If I take an app that only I'm working on and I move it into production, how do I exactly reproduce the database on the production server that I had in development? If me and 5 other people are all working on this application and I make a change to the database, how do I know that the other 5 in my group are all also going to get that same change made to the database in the same way that I made it? Right? In the old days, what most people used to do is they would simply record every SQL statement they wrote. So anytime you would write an SQL statement that would change the database in any way, shape, or form, you would mark it down in something like a log file, right? And then when you would take your website over to production, you would just go through and rerun every one of those SQL statements, copy and pasting one at a time if necessary. Right? If you were working with other people, right, then you would share that log file. You would put your stuff in, they would put their stuff in. Right? And anytime I added a new statement, somebody else would need to recognize that and would need to make sure they ran the same statement I did. Bless you, by the way. Right? There are still some problems with that, right? Like what happens if, for example, me and one other person are working on a website and very close to the same time we both make a change? Which change should be made first when we go to produce the master copy, right? Things like that can still cause a bit of a problem. And basically, migrations in Rails are supposed to help us get through a lot of those difficulties, right? What migrations in Rails basically are is they are like a log file where we write down every SQL statement we write, except Rails basically does it for us. Instead of us writing the SQL itself, we actually go to Rails and we announce our intentions to make a change to the database, one way or another. It then puts together a migration file for us. The migration files are all time-stamped, so it has an easy time telling what order they're supposed to be executed in. Right? And of course, it then has the ability to actually apply those migrations, to actually change the database based on what the migrations say to do. Right? So in the situation where I'm simply needing to move my development website into production, when I move it into production, all those migration files go along with the rest of the website. When I get it onto the production server, I just tell Rails, run all the migrations again. It goes through every step that I went through in development, so I should end up with a database on my production server that's exactly identical to what I've been using in development. Okay? If I'm working on a team with other people, we're probably using some type of source control mechanism. So every time I make a change to the database, I check my change, my migration file, basically into source control. Other people check it out, they run the migration, and their database then always stays exactly like mine. And vice versa. They check a migration in, I check it back out regularly, so that mine always stays the same as theirs. It tends to make things a whole lot simpler, right? The actual migration files themselves are pretty much all kept under the DB folder. Right? Under the DB folder, there should be a migrate folder there. And in the migrate folder is where you find all your individual migration files. Right? Here was the very first migration file, for example, we created for our books example. I executed a command on the command line telling Rails that I wanted to create a new model. I didn't even, in this case, ask for a migration. Right? All I said was I want to create a new model called books. But Active Record understands that creating a new model means that we're going to need somewhere to store the data for that model. So it translates that desire for a new model into a migration file so that we will end up with a new database table that is capable of storing the data that that model is supposed to represent. Right? So when I first created my books, I told it I wanted a title, an author, an ISBN, a page count, a publisher. I specified data type with page count. Everything else I just let it do the default string. Okay? And Rails or Active Record automatically put this migration file together for me. You see it's in a method called change. Right? Inside the migration there's a method called change. Depending on exactly what you do, there may sometimes be methods in here called up and down. Right? Basically what the idea is not only does Rails want to be able to keep track of everything we've done, but it also needs to be able to undo every step that we've taken. So if at some point we make a change to our database and we come to regret it, right? Active Record, the migrations give us an easy way to be able to roll back, to undo a change to a database, just like we'd hit Command Z, right, to undo something in an editor. Okay. So when there is an up and a down method, what happens is the up method always says when we're migrating forward, when we're moving forward with the development of the database, this is the change that should be done. When there's a down method with the up method, the down method says how to undo whatever it was that the up method did. Okay. Starting with Rails 3.1, when they could, they replaced the up and down method pair with just a single change method. Right? The change method is usually something unambiguous enough, something that can be undone without any additional information. Like here, the change method said create a table. So without a doubt, if we're rolling back, Active Record can look at that change method and say, well, if we created a table when we were moving forward, that must mean we're dropping a table to move backwards. Right? So pretty easy. I think all of our migrations just have change methods. That's where I added the in-stock column to my books table, added the price column, the most recent one we just did, to my books table. Okay? But overall, that's the basic idea behind why we have migrations and what they're supposed to do. Right? We've seen that creating migrations are really easy. We go out to the console. Rails has a built-in generator to help us create migrations. M-I-G-R-A-T-I-O-N. I think that's right. Doesn't look right to me for some reason. Right? We can basically say generate migration, and then we can give it some name. Migration test. Right. If I just run something simply like that, right, it goes ahead and creates a migration test file for me. You can see the name of the file that it created there with the timestamp on it, so it knows exactly when it was created and can get it to fall in the proper order if we ever rerun our migrations. If I go look at my new migration test file, in this case, because I didn't tell it what to do, it gave me the up and the down methods. So if I were to go in here and write specifically the changes I want to happen in the database, in the up method I would put in what I want to happen if we're evolving forward. In the down method I would say how to undo those changes. Okay. One way or another, at this point, that file is just a file. That's all it is. It hasn't actually affected our database yet. It's not until we go out to the console and run rake db migrate that it actually runs the migrations. Right? Rails always keeps track of which migrations have already executed. Right? So it always knows which migrations are new and need to be applied, which migrations have not yet been run. In this case, since I haven't actually run rake db migrate yet, if I change my mind about my migration called my migration test, I can basically just wipe it out. I could say Rails destroy migration test. And it gets rid of the file for me. I didn't even have to know the file's actual name. Did you notice that? I didn't have to put in the timestamp. I just told it the name the same way I put it in when I first created it, and it was able to reverse engineer what the file name should be and wipe it out for me. Pretty cool? Let me start a new project. I'm tired of this active record example. I'm tired of books. Let's go play with something else for a minute. Right? I just jumped up a directory. I'm going to go ahead and do Rails new, and let's make a to-do example app. To-dos, that's exciting. Books are boring, but to-dos, ooh, yeah, that's some good stuff. Yeah. I hit enter, generates my new project for me. It's running bundle install to make sure all the proper gems are there. Hopefully it won't take too terribly long. Oh, I was about to say so much for my hoping. Yeah. All right, change directories over to my new example, my new directory here. Let me shut down everything I have open in TextMate and open up this new project. There we go. All right, my to-do examples right now under DB, there is no migrate folder. There are no migrations. Okay? So if we wanted to start off building an app where we were going to be able to keep track of to-dos, like a to-do list, right? One of the first things we might want to do is we might want to create a model file. So on the command line, I could say Rails generate model to-do. So to-do would be the new name of my model. It would also then become the name of a new table. The table name would be pluralized, though. They would call it to-dos automatically. And I just need to specify types. I could say every to-do has to have a name. If I don't specify a data type, then it'll automatically default to string. Maybe I'll say that every to-do also is going to have a description, and with this one I don't want it to be a regular string, I want it to be text. More strings, basically. Longer strings. I'll hit the enter key. In this case, a handful of things were done for me. It created my model file where I can put in all my validations, all of those good sorts of things, custom methods. Created some testing code for me, and of course it also then created the migration. So under the DB folder, there is now a migrate folder, and under the migrate folder is the new migration that was just created for me for my to-dos. So in Ruby language, it created for me what needed to be created so that when I run that migration, the proper SQL will be written, a table called to-dos will be made that will have a name and a description field where name is a string and description is text. If I go back over to the console and I run rake db migrate, that'll actually execute that migration. So now in my database I have my to-dos table with the proper fields. Okay. What else can we do out here on the command line as far as controlling migrations? We can do rake db migrate to apply any pending migrations. Right? Well, there's a number of other options as well. If you ever want to know the things that rake can do, if you go rake -- tasks, it'll give you a list of all the built-in rake tasks. It's a pretty good list of them. What I'm going to do is I'm going to filter out and only look at the ones that have DB in them. My line's wrapped. Makes it a little hard to read. Oh well. I'm going to have to go too far down in font size to be able to unwrap it. Right? Essentially what we have in here, though, some of the crucial rake database-related tasks. We've got rake db create. Okay? That actually creates our database for us if the database doesn't already exist. Seems to me that usually when I run the first migration, that happens automatically. I can't remember the last time I had to manually run rake db create. But if I did execute it, it would create my database for me, right, if the database did not previously exist. Right? Rake db drop. right there. Gets rid of your database, wipes it out. So if you ever suspected you had some weird database issue, data corruption of some sort, you wanted to completely plow your database into the ground and start again from scratch, which migrations make easy to do, you could do rake db drop, wipe out your database, then do rake db migrate, and it would build the entire thing right back up again. Right? Fixtures load has to do with testing. There's rake db migrate, applying all of the waiting migrations. This is a handy one. Rake db migrate status. If you ever happen to lose track of whether you've run a migration or not, right? Maybe you import changes that were made to a project by somebody else who's working on the same project, and you need to know, do I need to run rake db migrate? If you do rake db migrate status, it'll tell you the status of all the different migrations. In this case, there's only been one migration, and you see it says the status is up, right? Meaning that it has been applied. It is in effect, essentially. Okay. What else did we have in there? Okay. RakeDB rollback, right, is like hitting undo. It takes us back one migration. Right. Schema dump, schema load. RakeDB seed is an interesting one, right? A lot of times a database may need to start off with some data already filled into it. You might notice that out there under that DB folder there's a file called seeds. What you can do in just regular old active record terms, like we were doing in the console, you can go through and you can create data that you want to have put into your database. Could be probably not test data, but starting data, seed data. I can't think of a better term for it than that. Let's see. In the database for my website, for example, I keep track of student status. A student can be enrolled, they can be withdrawn, they can be audit, right? Things like that. Well, those aren't pieces of data that I interact with directly. I don't go to student status, add new, because I'm not adding new student statuses every day. It's just a piece of data that needs to be available in the database. So I put it in as seed data. So if I ever move my application, my website, from one server to another, after I run the migrations, right, I just run RakeDB seed and it fills in that fundamental data for me again. Right? That's pretty much the idea, though. Lots of good things we can do. Okay, let's just fiddle with that a little bit. Let's say I want to add a new field to my to-dos table. Right? I'm going to do Rails generate migration. I'm going to say add due date to to-dos. And I'm going to tell it I want a new field called due date whose type is string. I could have just left the colon string off and string would have been assumed. I hit the enter key. Migration is generated for me, migration file. If I take a look at it, there it is. Based on the file name that I gave it, when I said add due date to to-dos, it figured out that that new column was being added to the to-dos table, so I didn't have to put that in myself. I could have named it anything I'd like, right? But it does help if your migration names are descriptive, of course. And if you happen to have the table name there at the end, you get the benefit of it also putting that in there for you. If it couldn't put that in there for me, I would have just had to have written this line myself. Oh, heavens no, that would have been tough. Okay. All right, now at the moment, that of course is just a migration file. If I want to apply it, I can do rake db migrate, and now my to-dos table in the database actually has a due date field of type string. Right? I could jump into the console, I could confirm that, I could use it, I could do whatever it is that I want to do with it. Right? But let's say at some point while I'm playing with that, I realize, oh, you know, string was a bad choice for data type. Due date should be a date time, probably, because I'm going to want to be able to say, is that now? Is that in the future? Is that in the past? I wish I hadn't made it a string. Right? Well, what I could do is I could roll back. I could do rake db rollback. Okay? What it did was it went back through that migration, right? Basically back to this file, looked at the change method and said, okay, we were adding a column to the to-dos table called due date. If we're rolling back, I guess that means we need to remove a column from the to-dos table called due date. So that's exactly what it did. Removed column from to-dos called due date. Pretty smart, isn't it? Yeah. If I decide that isn't what I wanted to do then, okay, I could do Rails destroy migration, add due date to to-dos, wipe out that migration file, and then maybe I recreate it. Rails generate migration, add due date to to-dos. This time I'll tell it to create a field called due date whose type is date time. There we go. I think that file's actually gone at this point. My new file, date time is the data type to the new field. And there it is. Okay. I could do rake db migrate at this point, actually apply it to the database. Or if I had other plans made, maybe I also thought of a couple other fields I wanted to add, I could go ahead and do that. I'm going to say Rails generate migration, add priority, and complete to to-dos. I'm going to say make priority an integer, make complete a Boolean. That makes the new migration for me, adding 2 different columns this time. If I say rake db migrate status, oops, which you got to spell correctly. Seriously, you do. There we go. So it shows my first migration, the one that created the to-dos table, is up. Essentially, it's been applied. The other 2 migrations that I've created are both shown as being down because they have not yet been applied. If I go ahead and do rake db migrates, just rake db migrate, it applies all of the waiting migrations. So the one that sets up the due date column as a date time and the one that adds priority and complete, they all get put in. If I take a look at the status again, they all 3 show as being up now. The only other thing I might mention here real quick, I hate to leave this hanging because it's the last little thing I want to mention to you about migrations at this point, right, is that migrations very often involve putting in what are sometimes referred to as magic columns. Magic columns are basically additional columns of data in our models that we don't usually specifically ask for, but Rails puts in anyway because of convention or just because it's generally a good idea. Right? Things like making sure that every record has an ID. Right? Notice we never specifically said, nor was it ever shown to us, that a record had an ID, but Active Record always makes sure that every record in every table has an ID. Everything's always going to have an ID. Also, when we start playing with relationships between tables, we'll see that Rails will automatically generate foreign keys. The foreign key field names will always be the foreign table name underscore ID. Right? Another bit of convention there. Rails always does it that way. Okay. We've seen the date and time columns that it puts in automatically. Created on and updated on, or created at and updated at. Right? Basically, if it ends in on, it only stores the date of the change. If it ends in at, it saves the time and date. date. You can get either one if you want it, but typically it's the time and date that's put in for us automatically. Right? There's a couple of other magic column types. There's one that's always the name of a table followed by underscore count, which is basically a count cache. That's one you start dealing with when you have related tables. Like if we had a blog model and a blog had many comments. Right? A blog item had many comments. A blog post, I guess I should say, had many comments. Well, if counting the number of comments that went with a particular blog post was something we did commonly, we could ask Rails to put in a count cache for us, where it would automatically keep track of the number of comments without actually having to hit the database and physically count the comment records that were related to that blog post. It's an efficiency thing. Right? There's also a magic column type we can put in called type. The actual name of the column is type. It's something that we'll fiddle with a little bit. It's something that happens anytime you do what's called single table inheritance. It's essentially a situation where a table refers back to itself as a relationship. So if we had a table of people and we were specifying relationships between people, one record in that table was related to another record in the same table instead of a record in a different table. That kind of thing. Okay? So anyway, a little bit about migration, a few extra little tools that I hadn't mentioned to you before. But I think that's pretty much it. Fiddle with them, play with them. Go out and just make some trash migrations, run them. You remember you can do Rails DB and actually go in and peek at the database. So I could do Rails DB and type .tables, and it'll tell me what tables I have. Right? I can, of course, do my regular SQL. I could select all from to-dos. Oops, forgot my semicolon. All that kind of stuff. So just fiddle with it. Fiddle with it all a little bit. Play with your migrations, create them, apply them, undo them, roll them back, change them. How could you not? So much fun. .exit will get me back out of there. Are there any last questions I could answer before we cut it off for today? All right. Next time I want to get into, like I said before, Active Record Round 2, maybe call it more advanced Active Record. We need to talk about callbacks, and we need to definitely start working with relationships. So relationships between multiple models, which of course means between multiple tables. So that'll be next time. Right. Hope you all have a good afternoon. See you, Thursday? Today's Tuesday, right? All right, Thursday.